In this video, I will go over some fundamental theorems. Now, I'm gonna start. I have written everything here. I will start with the fundamental theorem of calculus. This is the one that we're probably familiar with. If you have an integral from a to b of a function uppercase f of x, and you're integrating over over x, if you know, okay, if this is what you have in your integral, if you know the function, the lowercase f, whose derivative is equal to this, what you have on the integral, then this integral is equal to the value of the function f at b minus the value of the function f at a. So this is the fundamental theorem of calculus. We are familiar with this. We're using it all the time. Now, we also have, if you have a scalar function, the integral when you go from position A to position B, and I want to make it clear, okay, that's a vector, and this is also a vector. So this integral between the dot product of the gradient of the function f dot dl, and this means the fact that you're integrating, that you go from one position to another position, and you're following a path. This is a path integral. Now this will give you, this is equal to the value of the function f at position b minus the value of the function f at position a. Now this is a scalar function, okay? If you use let's say x, y, z, then you get a value at that point. If you change the coordinates, you get a different value. So this function does depend on the coordinates. That's why it depends on the specific position, and this path integral of the gradient of that function is simply the function at b minus the value of the function at a. Now there are some things that are that we can conclude from this. As I said, this is a path integral. Okay, so here what I have is a path integral. But I want you to pay attention to the right side. The right side is telling me that this path integral depends on the value of the function at b and the value of the function at a. No matter what path you choose, you will always be getting the same result. What this is telling us is that the path integral of the gradient of the function does not really depend on the path. That was one. And also, because this is a path integral, if you start at point A, you follow the path, you come back at the same point A, then you'll end up having the value of f at A minus the value of f at A. You will get 0. So the path, if you calculate the path integral of the gradient of the function, and you start from a point and you end up at the same point, you will get a 0. So the closed, so if you go around the circle or around any closed path, you will get a 0. Alright, the next one is about the divergence. Now what I have here, this is a volume integral. And on the right side, I have a surface integral. The left side is, so this is an integral over a volume. the left side includes the volume integral of the divergence of the function f, and the right side is a surface integral of the dot product with dA. Now this is a closed, okay, let me make a note. This is a closed surface integral. So this is the fundamental theorem for divergence. And the last one is the fundamental theorem for curl. Here I'm integrating, this is a surface integral, the surface integral of the curl of the vector function f. I forgot to mention this before. Here the function f is a vector function, okay? Here it is a scalar. So here my function f is a vector function. I'm calculating the surface integral of the curl. This is equal to the closed path integral of the vector function dot dl, and this is the fundamental theorem of curl. And in this video, I hope I gave you a nice overview of these four different fundamental theorems.